Now, well in advance, I'm informing to you, current is not there from past 2 hours. Classes I'm taking from past 2 hours on inverter. So suddenly, if everything is becoming black, my cell phone is switched off, then simply you log off. Because simply sitting in front of the system by keeping your camera on is of no use. Why? Because if current is not there at my area, so well in advance, I'm informing you, correct? It is there from past 2 hours, but from past 2 hours, I'm taking classes continuously. For you also, I'll take continuously, but well in advance, I'm informing you so that if any connectivity link is there from my side, simply you withdraw, log out, and read yourself. If there is no connectivity issues are there, listen class properly up to 12:15 without any hindrance, without any hiccups. So come for the topic, doubt clarification. And yesterday, I'm very sure that I have completed objective 1. Again, asking any doubt left over in the objective 1 from my side, I have done, but still again asking.
No, sir.
Sure. As no doubt is there in the objective 1, and now I'll go for the what? Objective 2. Objective 2, already all the typical questions already I have done the day before yesterday only. I have done on the Monday. Let us come for the objective 2, and I'll go same old trick in multiples of the 5, and in that multiples of 5, in between number of questions I have done. But if you're having doubt, definitely you ask. $46 to $50.
48, sir.
Now coming for question number 48. Question 48 is as it is putting on the formula. As means as it is whatever they have given, putting on the formula. It is such a good question. It is there that for this question, concept is not there. Understanding is not there. Formula based question. Whatever the formula it is there, in that, whatever the terms are given, substitution of the terms it is there. So in the question, what is main question asked? Main question asked is then the ratio of the mole fraction of the oxygen and the nitrogen is. Ratio of the mole fraction of oxygen and nitrogen. Now I go for in this way. I go for the partial pressure of the oxygen. Partial pressure of the oxygen is nothing but equal to kH of the oxygen and mole fraction of the oxygen. I'm not writing in terms of the number of the moles because question is straight away asked the ratio of the mole fraction it is there. So if I go for the here partial pressure of the nitrogen, then this is nothing but becoming kH of the nitrogen, and this is nothing but becoming mole fraction of the nitrogen. This is the question asked. Mole fraction of oxygen by mole fraction of nitrogen. This you have to cross multiply here. This you have to cross multiply here. So I will write mole fraction of oxygen, mole fraction of nitrogen is no change as it is PO2 and PN2. This you are multiplying this side. So this is becoming Henry's constant for nitrogen gas. This you are multiplying downside, and therefore it is becoming Henry's constant for oxygen. Now, whatever the terms you know straight away, whatever the terms you know, put the value. Very clearly in the question they have given Henry's law constant and kH value for the both oxygen and the water, nitrogen they have given. For oxygen, they have given 3.3. For oxygen, they have given 3.3 into 10 to the power of 7 torr. For nitrogen, they have given 6.6 into 10 to the power of 7 torr. Check same value they have given.
Yes, sir.
Now coming for the, if I'm going for the partial pressure, if I'm going for the partial pressure, if I'm going for the partial pressure is indirectly given. Oxygen is 0.2 and nitrogen is 0.8. No, sir, how 0.2, 0.8? Total pressure is 1. How 1, sir? 0.2 plus 0.8 is equal to 1. Out of the one contribution of the oxygen is 0.2. So partial pressure of the oxygen will be 0.2 and nitrogen 0.8. This I will go for 1 by 4 times. This I'll go for the 2 times. 2 2s are 4, and therefore it will be, answer will be 1:2. Tuba Mab, why you are entering late? Tuba Mab. Tuba, you enter 10 minutes late. Prakash, 10 minutes late entered.
Yes, sir. Yes, sir. Sorry.
Anyone doubt in this question, beta?
No,
sir.
Anyone doubt up to question 50?
sir, 49, sir.
49. 49
50.
again, bit of formula based question. Straight away putting on the formula. Let us first go for the main question. What is the main question asked? Main question asked is the quantity of the carbon dioxide in grams. Check, they have given ... fill up the blanks, and then they have given what grams. The question is asked quantity of the carbon dioxide in the grams. So this I am rubbing it, and now I am going for the another question, and this is a straight away substitution. First going for the main question. Main question is saying amount of carbon dioxide in grams is equal to number of moles of carbon dioxide into gram molecular mass of carbon dioxide. Number of the moles of the carbon dioxide will get from the Henry's law. Gram molecular mass of the carbon dioxide, we know very well it is 44, it is it. Now to calculate number of moles of carbon dioxide, I'll apply Henry's law. And Henry's law is saying partial pressure of carbon dioxide, kH of the carbon dioxide, number of moles of carbon dioxide divided by number of moles of water. Number of moles of carbon dioxide I have neglected in the denominator. Why? Because long back, near about 15 days back, concept I have taught you that the number of moles of solute is very, very less in comparison to number of moles of solvent, and therefore in denominator you will take only number of moles of the solvent. Our question is number of moles of carbon dioxide. So I will write number of moles of carbon dioxide is a partial pressure of carbon dioxide into number of moles of water divided by kH of the carbon dioxide. Let us put the values one by one. I'll go for the partial pressure of carbon dioxide. Partial pressure of carbon dioxide, they have given 2.5 atm. KH value they have given 1.6, 1.67 into 10 to the power of 8 Pascal. You should be very, very careful. One you can't take in the Pascal, one you can't take in the Pascal, one you can't take, another you can't take in the ATM. Both you have to take either in the Pascal or either in the ATM. Purely your wish it is there. Purely your wish it is there. And you know very well from your atomic structure, you know very well that 1 atm, or from the gaseous state, 1 atm is equal to 1.01325 into 10 to the power of 5 Pascal. It is there. This you know very well. 1.01325 is nothing but roughly equal to 1. So this I'll multiply as 10 to the power of 5. Now this 2.5 atm is transformed into Pascal. Now coming for number of moles of water. How to go for number of moles of water? Number of moles of water means weight divided by gram molecular mass. Weight is a 500. In question number 46, question number 47, I have done long back. In question number 46 and 47, I have taken 1000 by 18. In
Yes,
question
sir.
46 and 47, weight of the water was 1000. But in this question, it is not 1000. It is clearly in the question they have given 500 ml of soda water. 500 ml of soda water means 500 grams of water. And therefore, here I will write 500 divided by 18. On solving this, we'll get the answer.
Thank you, sir.
Any doubt up to question 50? 51 to 55?
55, sir.
Yes, sir.
55 again, formula based question. Straight away, beta, you're asking the formula, straight formula question. And question 55 is just like question number 71 of objective 1. Turn the pages. Question number 71 of the objective 1. It is just like question number 71 of the objective 1. I'll solve on the blackboard. I'll put on the blackboard, and then you will only tell me, are correct, sir? It is just like question number 71. I'll help you as you have asked. Definitely, definitely I'll help you. You know very well there is no question of denying it, but definitely I'll remind all of you, the girl or the boy who is asking question to me, I'm not reminding to them only. I'm reminding to each and every one of you that same type of the question we have done earlier. I'll go for question 55 and the trick I have taught you. When in the question, vapor pressure it is there and weight of the solute and the weight of the solvent. Weight of the solute, weight of the solvent, vapor pressure, only one formula we are having. And what is that formula? That formula is nothing but our relative lowering of vapor pressure formula. P naught minus P by P naught is equal to W by M into M by W. First, let us go for the solute. Clearly in the question, they have mentioned that 139.18 grams of glucose. Glucose is a solute, so 131.8. 139.18, I'm sorry. 139.18 glucose. We know very well glucose is this one. So from this, its molecular mass is
180.
Solvent is a water. It is an aqueous solution. It is there. Clearly in the question, they have mentioned aqueous solution. And for water, molecular mass is 18. And the weight of the water, again, they have given in the question as 178.2. Now, question is asked calculate P. Calculation of the P requires value of the P naught.
Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium, scandium.
Hello. Some your mic is open. Your brother or the sister may be sitting beside you, or maybe your mummy or daddy is taking class. That is the reason why sodium, potassium, all those things is going on.
Sorry, sir. I'm so sorry.
Yes. If water is a solvent, clearly mention water is solvent. We know very well boiling point of the water is 100 degrees Celsius or 373 Kelvin. In the question, clearly they have mentioned 100 degrees Celsius. 100 degrees Celsius means boiling point of the water. And yesterday I have given to you at boiling point, vapor pressure of the liquid is equal to atmospheric pressure. This you are not forgetting. At boiling point, vapor pressure of the liquid is equal to atmospheric pressure. So at temperature of 100 degrees Celsius, vapor pressure of the water is equal to atmospheric pressure. Atmospheric pressure means maybe 1 atm or maybe 760 of mercury. All the four options they have given in terms of, don't forget, 1 torr is equal to 1 So 760 is equal to 760 torr. So from this, it's very clear that this value is a 760 and this value is a 760. So what I will do, this I'll cross multiply here and exchange the positions. So on cross multiplying here and exchanging the position, P is equal to 760 minus 139.18 into 18 into 760 divided by 180 into 178.2. Make it. So here, what is the basic thing? This is the basic thing. They have given 100 degrees Celsius. For water, 100 degrees Celsius is not any value. It is boiling point of water. And at boiling point, vapor pressure of the liquid is equal to atmospheric pressure.
Thank you, sir.
Anyone doubt in this question?
No, sir.
Now, based upon this question number 71 of the objective one and this question, they are the very common question coming in the examination. Very means very common, because this value they will give you. This value they will give you from 100 degrees Celsius or 373 Kelvin. You are getting idea. 56 to 60.
59.
Yes, sir. 59.
59 concept I'll teach you once I'll go for the colligative property. Leave question 59. After colligative property, I'll tell you. Leave question 59 for time being. 59 to 60.
60, sir.
60. Question is asked the molecular weight of the solute. Each and every term is given. Those who is asking question number 60, even single time also you have not tried at home better. Single time also you have not tried at home. Simply bluntly you are asking the question, because by the way of the question I'll get the idea whether you have tried or not tried. Yes, you have not tried first time also. You have not tried a single time also. First time you're asking the class. Question is asked, calculate the molecular mass, weight they have given, vapor pressure they have given. Let us go for the P naught. Clearly they have given vapor pressure of diethyl ether is 440. Don't forget, always P naught will be greater than P. Two values they have given, so higher value will be P naught, and P naught is nothing but 442. It is a 442, and after adding the solute, now it is becoming 410. Clearly in the question is mentioning falls to 410. It is falling to 410. It is there. Now coming for the weight. Weight, clearly they have given 6.4 grams. It is 6.4 grams of the non-volatile solute. And for this, molecular mass is a question mark. Clearly in the question is saying that clearly that 50 grams of the ether. So weight of the ether is 50 molecular mass. In the question they have mentioned diethyl ether. This is the formula for diethyl ether. Carbon is a 12, 12, 24. 24 plus 5, 29. 29. This is a 29. This also 29. And oxygen is a 16. 29, 29, 58, 58 plus 16 is a 74. By this, calculate M. This doubt clear better?
Yes, sir.
Okay, good. Any doubt from 61 to 65? Any doubt from 61 to 65? I remember 61 I have not done, 62 I have not done, 65 I have not done. Any doubt from 61 to 65? Fast, don't kill my time.
No, sir.
Check properly. Check properly. Once I'll go for objectives 3 and 4. 65. Now I'll go for 65. 65, you will get nearly correct answer. Exact answer you won't get. Exact answer you, yes, exact answer. Same problem you're having?
Yes, sir. Simple.
Yes. Exact answer you won't get. You'll get nearly correct answer. You'll get a nearly proper answer. Therefore, well in advance, I have informed you. But definitely, I'll go for question 65 because question number 65 type of the question I have not done. 65 type of the question I have not done day before yesterday. Whatever the question till now I have done, everywhere I am going for the mole fraction of the solution. But here we are going for the mole fraction in the vapor phase. Check clearly in the question they have mentioned mole fraction of toluene in the vapor. Mole fraction of toluene in the vapor means I'll go in this way. YT, hey, T is a toluene, not total. T is a what? Toluene. So YT is equal to P naught TXT divided by P naught TXT plus P naught BXT. Don't forget P is for the toluene and B is for the benzene. It is there. Now, this is a question mark. It is there. Clearly in the question, they have mentioned that vapor pressure of the water, the vapor pressure of the benzene and toluene. Benzene is at 28 and toluene is 95. Benzene is, how much they have given? Benzene is a 28. Benzene is a 28. This value they have given 28. And toluene they have given as an 95. Benzene is at 28. Toluene they have given 95. Let us go on solving the question. And they have given the molar ratio is a 2:3 for toluene. Means number of moles of toluene is a 2. Number of moles of benzene is a 3. That they have given 2:3. 2 for the toluene and 3 for the benzene. Keeping this in the mind, can I say mole fraction of toluene is a 2/5? Can I say?
Yes.
So can I say mole fraction of benzene is a 3/5? So
Yes.
as it is a mole fraction of toluene, so this you are multiplying with the 2/5. This you are multiplying with the 2/5. And this you are multiplying with 3/5. And then you are solving. You will get nearly correct answer. Whatever the options they have given, exact option you won't get matching. So whichsoever the option is nearby, you'll go for that answer.
Sir? Sir, haven't they mentioned the vapor pressure directly? It's not the pure pressure of benzene and toluene. They've directly said vapor pressure at that temperature is 28 and 95. So mole fraction won't be required there, right?
For this type of the question, actually, they have to mention the vapor pressure of the pure component only. Whenever they are mentioning, they have to mention the vapor pressure of the pure component only. They have to mention. They have to mention the vapor pressure of the pure component only. Let us go in that way. If whatever your language is correct, if you're correct, then we'll get the answer nearby. Problem is not there. Let us cross check it. There is no harm in cross checking. Now I'll go for the white. So this is nothing but, can I say PT divided by PT plus PB, can I say?
Yes, sir.
Yes.
Can I say?
Yes.
PT, as the girl is saying that, let us, as they have not mentioned the pure straight away, there's no harm in trying. For the benzene, they have given as a what? 28. So for benzene, they have given as a 28. This they have given 95, and this they have given 28. Try by this method. If getting answer correctly, then this method is the best method. Problem is not there. Check.
So with the above method, you're getting 0.71, and with the below one, 0.77. So it's
0.7.
both of them are giving nearly same answer.
Nearly same answer, because this question is a previous IITG advanced question when people were not born. Since that time, this question is coming, and that is the reason why, as the girl has asked me the question, clearly I have mentioned that here you won't get the proper answer, you'll get the nearby answer. So
Sir, first one is more close to the answer.
So whether you solve by this or solve by this, and yes, we have to go on the way which is more means more nearer. So from this, it's very clear that whatever the value they have given, 28 and the 95, 28 and the 95 is nothing but it is what? Vapor pressure of the pure benzene and the pure toluene, it is it. Anyone doubt up to question 65? Anyone doubt up to question 65? 66 to 70. 66 to 70.
67.
66 to 70. 67. 67 is a star mark question. 67 is the star mark question. Why star mark? It is easy question, therefore star mark. Too much is there, sir. Easy question, then why it is a star mark? In this question, speed thrills but kills. If question 67 you are not observing properly, you will be in the illusion that you are correct. You will be in the illusion that you are correct. And it is a very common question coming in the examination. Very common question coming in the examination. I'll tell you in what illusion you will be there. You know formula that P naught minus P by P naught is nothing but mole fraction of solute. P naught minus P is nothing but change of pressure. So this I will write as a delta P divided by P naught is equal to mole fraction of the solute. For a given solvent at given temperature, P naught value is a constant. For a given solvent at a given temperature, P naught value is a what? Constant. Now I'll go for the condition. Clearly in the question is saying that 10 mm lowering of the vapor pressure it is there. When 10 mm of the lowering of the vapor pressure it is there, that time mole fraction of solute is 0.2. It is 0.2. Then question is saying, if 20 mm lowering of the vapor pressure it is there, so if 10 mm mole fraction is 0.2, if 20 mm, can I say mole fraction is 0.4?
Yes.
Yes, sir.
Hey, and you people are thinking this is the answer. This is not the answer, beta. It is mole fraction of solute. Check what is question asked.
Mole fraction of solvent.
Solvent.
1 minus 0.6.
So mole fraction of a solvent is equal to 1 minus 0.4, 0.6. 99.99% boys and girls are getting this answer and they are stopping at this only. And then after some time, when they will again check, cross-check, answer is wrong. Answer is wrong because this is correct, but this is not the answer. Question is asked mole fraction of solvent. Now, anyone doubt up to question 70?
69.
69, the vapor pressure of an aqueous solution of Bala, remove that fellow. Now, question 69. The vapor pressure of water at room temperature 23.8. The vapor pressure of an aqueous solution of sucrose with mole fraction 0.1. Straight away they have given. Straight away means straight away they have given. Straight away they have given. very straight away. Clearly, they have given that vapor pressure of the water is 23.8. Water means pure solvent. This is question mark P. Straight away, they have given mole fraction of the solute is 0.1. Straight away in the question given 0.1 mole fraction. So simply cross multiplying. So P is equal to 23.8. This on cross multiplication becoming 2.38. That's it. Any doubt up to question 70? Any doubt in objective 2 left over? Any doubt in objective 2 left over? Now coming for objective 3. Objective 3, not any questions based upon test portion. Whatever I have marked, you're asking that only. Any doubt in objective 3, whatever I have marked? Any doubt in objective 3, whatever I have marked? I am bothered regarding these few questions. I am bothered regarding question 22. I am bothered regarding question 23, question 25, and question 26. These are the very common question coming in the examination. If I am going for 24th, which of the following is incorrect for ideal solution? For ideal solution, delta H mixture is equal to 0. It's correct. Delta U mixture is equal to delta U mixture is equal to 0. It is not U, make it delta V. It is a delta V mixture is equal to what? 0. It is there. If I am going for the 22, third option, delta P is equal to observed pressure minus calculated pressure. That's correct. Delta P is nothing but change of pressure. The change of the pressure is nothing but pressure observed minus pressure calculated. Delta G mixing is 0, not 0, it is negative. This is the star point I have given to you. Whether it is an ideal solution or non-ideal solution, formation of a solution is a spontaneous. As the formation of solution is a spontaneous, and that is the reason why for that delta G value will be negative. Coming for 23rd, if molality of the dilute solution is a doubled, molar depression constant, I have not taught you. It is a coming topic. So question number 23, I'm cancelling. Question 25, for an ideal gas, delta H mixing is equal to 0 at constant temperature and pressure. Therefore, first option. For ideal, delta H mixing is equal to 0. Delta S mixing is equal to positive. Delta G mixing is equal to negative. Therefore, only first option. Question is saying maximum boiling point azeotrope. Maximum boiling point azeotrope means negative deviation. That's very good. Negative deviation. Negative deviation, best example is water and the nitric acid, which in the class also I have given to you. And in the examples, I have put star mark. This is an NCERT example. It is there. So any doubt left over in objective 3?
No.
No.
Now coming for objective 4. Again in objective 4, whatever the questions I have marked, that questions only. Whatever the questions I have marked, that questions only. And Bala, in your class, anyone by the name Syed Nazif is there? If it is there, ask him to come with the ID number. He is entering without ID number, therefore I'm not taking him. Yes. Without ID number, I am not taking him. Now coming for question number 3. Question number 3 and question number 4. Question number 3 and 4 are the star mark question or star mark question. Which of the following solution pairs can be separated by, question is saying, can be separated by the water distillation, can be separated by distillation, and answer is third option. Answer is third option. In question number third and the fourth key correction, it is there. So for question number third, answer is third option. Answer is third option. Why answer is third option?
It is not forming azeotrope.
Benzene and the toluene are forming ideal solutions. Ideal solution does not form azeotrope. When they does not form azeotrope, they can be separated by fractional distillation. So go for a key change. For question number third, answer is third option, not second option what they have given. Question number fourth. An azeotropic mixture of water boiling point 100, HCl boiling point 85, boils at 108.5. Boiling point of both the components, if you check, boiling point of both the components, water and the HCl, is less than that of the azeotrope. Means the boiling point of the azeotrope is more. When the boiling point of the azeotrope is more, it is nothing but called as a maximum boiling point azeotrope or negative deviation. Question is saying, when the mixture is distilled, it is possible to obtain fourth option, neither HCl nor water in the pure state. So for the fourth, they have given third option. Go for a key change. Answer is the fourth option. Answer is the fourth option. Therefore, in the class I have mentioned, in azeotropes, the two components cannot be separated by help of fractional distillation. So in the question number third, key change it is there, and proper answer is third option. In question number fourth, key change it is there, and proper answer is fourth option. Apart from these two, any question, doubt?
Sir,
Question number 13th.
yes, sir.
An ideal solution has two components, A and B. Question is saying A is more volatile. Question is saying A is more volatile. If A is more volatile, then definitely P naught A is what? Greater. Then definitely P naught A is greater. And question is saying that P naught A is greater than that of the P total. Then that of the what? P total. Question is asked if XA and YA are the mole fractions in the liquid and the vapor phase. Clearly, I am mentioning A is more volatile. A is a more volatile means A will leave the surface with a difficulty. A will leave the surface with a difficulty or with easiness?
With easiness.
With easiness. So can I say A undergoes vaporization very easily?
Yes, sir.
If A undergoes vaporization very easily, means amount of the A will be more in the vapor and less in the liquid, can I say?
Yes, sir.
Can I say?
Yes, sir.
Yes, sir.
A is there and B is there. A is a more volatile, means A easily undergoes evaporation. B is also going evaporation, but the rate of the evaporation of the B is less in comparison to A because we have assumed A is a more volatile. So here we will have both A plus B. Both A plus B. Here also we will have both A plus B, but in the solution, mole fraction of the B will be greater than that of the mole fraction of A. In the vapor, both A and B are there, but mole fraction of A will be greater than that of the mole fraction of the B. So more volatile component will be more in the vapor form and less in the liquid form. Keeping that in the mind, can I say fourth option?
Yes, sir.
Yes, fourth option. YA is greater than that of the XA. Any question which I have marked?
No,
Any
sir.
question which I have marked? Now test portion has been completed. Test portion has been completed. Again, I'm asking. Okay, I'm taking first this fool. Syed Nazif. Syed Nazif, you are in online classes from past 1.5 years. and still you want information that you have to come along with ID number? Tell me.
I'm sorry,
Tell me.
sir. I changed my name.
I know very well. I know very well you are from this class only. But you know very well from past 6 months or 7 months, different imposter boys and girls are coming in the class with the same ID number. With the same ID number. Therefore, enter with ID number. What is there?
Okay,
Now,
sorry, sir. I'll change it now.
From objective 1 to objective 4, any doubt in test portion? Any doubt in test portion, so that test portion successfully completes, I'll start a new topic, colligative properties.
So objective 1, question number 47.
Objective 1, question number
47.
Objective 1, question number 47. Question number 47 is in last week's syllabus, not this week's syllabus. Last week's syllabus, leave it. This week you are not having Henry Islami, correct? What is this week test portion? Therefore, leave it. With last week questions over. Last week question asked last week only. And in this, if you'll solve, I'll tell you, in question number 47 also, answer is not 0.97, answer is 0.917. Go for correction. In question number 47, if you'll solve, answer is not 97, 0.97, it is 0.917. Now you may get answer.
Yes, sir. Thank you.
0.917. Any doubt in the test portion? Any doubt in test portion? Now I'll go for the colligative properties, because chapter name is solutions and colligative properties. Now I'll go for the colligative properties. I'll go for the colligative properties. So first I'll give you something oral, and then I'll come on the topic. Colligative properties are the properties of dilute solutions. Straight point. Colligative properties are the properties of the water dilute solutions. Colligative properties does not depend upon the nature of the solute particles. Colligative property does not depend upon nature of the solute particles. Colligative properties depends upon the number of the solute particles. Point number 1. Colligative properties are the properties of dilute solution. What is second point? Colligative properties does not depend upon the nature of the solute. They depends upon the number of the solute particles it is there. Now, once you got the idea, same thing I write on the blackboard. Topic is colligative properties. Topic is colligative properties. So I will write, they are the properties of dilute solutions. Point number 2. They are independent. They are independent of nature of solute. But depends upon number of solute particles. But depends upon number of solute particles. Different nature solute particles. Different nature solute particles will have same value different nature solute particles will have same value of colligative properties if number of particles are same. It's a very interesting point. So different nature solute particles will have the same value of colligative properties if number of particles are same. And a long back, I have informed you that why, or taught you why we are reading this topic, colligative properties. Why? Why? To calculate the molecular mass of the solute, to calculate the molecular mass of the unknown substance. Oh, solution is a very great chapter, number one chapter, not number one chapter, not great chapter, not last chapter. By help of this topic, solutions and colligative properties, we are there in the position to calculate the molecular weight of the, or molecular mass of the unknown substance or the unknown solute. So different nature solute particles will have same value of colligative properties if number of particles are same. Anyone doubt in these 3 points?
No, sir.
Now I'll rub. The 4 colligative properties are relative lowering of vapor pressure, which just now I have completed for you, elevation of boiling point, depression of a freezing point, elevation of boiling point, depression of the freezing point, osmotic pressure. Osmotic pressure, write in the proper way. Don't write BP, don't write FP, don't write OP. Relative lowering of vapor pressure, elevation of boiling point, depression of the freezing point, and osmotic pressure. These are the only 4 colligative properties used or known to us. And I have taught you what is the purpose. What is the purpose? Colligative properties are used. Colligative properties are used to calculate molecular mass of non-volatile solute. So this is the main purpose why we are reading colligative properties, to calculate the molecular mass of the non-volatile solute. Copy it?
Yes, sir.
Understanding point, star mark. Understanding point, star mark. Vapor pressure is not an colligative property. CP means colligative property. Vapor pressure is not an colligative property. LVP is not an colligative property. Lowering of the vapor pressure is not colligative property. Only Relative lowering of vapor pressure is a colligative property. Boiling point is not colligative property. Freezing point is not colligative property. Very, very careful. Elevation of boiling point is a colligative property. Depression of the freezing point is a colligative property. Boiling point is not a colligative property. Freezing point is not a colligative property. Vapor pressure is not a colligative property. Lowering of vapor pressure is not a colligative property. Very common question coming in examination. Done?
Yes, sir.
You should be very, very careful. Only relative lowering of the vapor pressure is the colligative property. Elevation in boiling point is a colligative property. Depression in freezing point is a colligative property. It is there. Depression in freezing point is a colligative property. It is there. Now, just understanding. What is the boiling point of water? Pure water.
100 degrees.
Yes,
100 degrees Celsius. You try at home. If you're at home, thermometer is there. Not clinical thermometer. If you're having the other experimental thermometer, it is there. Then boiling point of the water is 100 degrees Celsius. In the water, you add pinch of NaCl. Only pinch of NaCl. Only pinch. Again, go for the heating. And you will observe that this boiling point is 102 degrees Celsius. Earlier 100, now become 102. So boiling point is elevated or boiling point is depressed?
Elevated.
Elevated. And that is the reason why word is there called elevation of the boiling point. So when you are adding any impurity, salt is an impurity. If you are adding any impurity to the pure solvent, its boiling point is raised, its boiling point is increased, and therefore the word is elevation of the boiling point. Now we are having in the mortuaries, we are having boxes are there, coffin boxes are there now. They are completely refrigerated, just like refrigerator it is there. But in the good olden days, that condition was not there. In the good olden days, dead body should not decompose or the decay, and that is the reason why big slab of the ice, 7 feet in the length, yes, 7 feet in the length, 4 feet wide, this type of the big slab used to be there, and on that ice slab the body used to be kept. But again question arises, no sir, but we know very well that melting point of the ice or the freezing point of the water, it is nothing but 0 degrees Celsius it is there. But in the mortuary, temperature is not 0 degrees Celsius or no. So ice will melt. Yes, ice will melt. And therefore, what they used to do, by help of the screwdriver, they used to break the ice and make ice into small lumps. And in that, they used to add 1 kg of a salt or this much fistful of the salt. When they are adding the salt, whatever the freezing point of the water, it is there. It is 0 degrees Celsius. But when ice is added, it is becoming minus 11 degrees Celsius. Minus 11. From 0, it is becoming minus 11. So it is a depressed or elevated?
Depressed.
Depressed. And that is the reason why I have used the word depression in the freezing point. So inside your mind, you take two fundamental things. If in the pure solvent water, you are adding impurity, it's not water, any solvent. In a pure solvent, if you are adding any impurity, its boiling point will be raised and freezing point will be depressed. As the boiling point is raised, and therefore the term is elevation of the boiling point, and as the freezing point is depressed, and therefore term it is what? Depression of the freezing point. Something better? Someone has shared something? Any girl or the boy, but I'm unable to understand what you have asked or what you have shared.
No, sir, I was telling freezing of the freezing point. I was repeating the point which you're telling.
Okay, sure. So from my side, each and everything completed. Test portion completed, colligative properties started. And Thursday, Friday, Saturday, I'll go for the colligative properties only, because test portion revision completed, test portion number of doubts completed, each and every question completed. So from tomorrow onwards, I'll go in detail of the what colligative properties. Let us meet tomorrow at same time. See you. Thank you.
Thank you, sir.
Bye, sir.
Thank you, sir.
Thank you, beta.